Okay. All right, welcome to the Cluster API project meeting. This is Wednesday, December 19th, 2018. If you are in attendance, please add yourself to the attendees list and the meeting notes. I'll post that link in the chat. And if you have any topics or questions, please add them there as well. And it looks like, actually, just to recap, last week there was a meeting that took place during KubeCon, and it was on Wednesday also, but it was a slightly different time. I know some people joined, and we took notes, and they were also in the agenda doc, and there's a link to the recording. We discussed sort of HA, what HA or highly available clusters sort of meant to various parties in the Cluster API project, and yeah, now we're sort of back to our regularly scheduled programming. I think last week we. At least I'll try to give a quick summary, I guess. I'm not sure that we reached consensus on exactly, the way forward for highly available clusters, but we heard, ideas. We heard ideas from the Gardner project, how HA is handled there. We talked about whether we would need to handle etcd clusters as part of Cluster API, and so it was just kind of an exchange of ideas, but not, as far as I understood, there wasn't any sort of consensus on what we should do. I think a few people did voice the idea that there's sort of time for experimentation, and that once we try some approaches rather than just talking about them, we can see we can judge them based on how they work, and then perhaps adopt one or perhaps more approaches to HA in the sort of the common Cluster API code. And that's all I have, I think, for last week. And it looks like the next topic on the list there is from I think Mysim. Do you want to take that?
Yeah. So we've had a lot of discussions about the machine APIs working without the cluster object. So this PR that I sent is pretty straightforward. All it does is that it goes all the way to the actuation layer. So it will call the machine actuator, but it might call it with a nil cluster object. And that's a primary difference between the behavior of today and the new behavior that this introduces. It also, we feel like this is the right way to go, regardless of the direction, because it allows the machine actuators to actually take some action without being completely blocked. This does, however, mean that that all the providers would need to actually write machine actuators which expect a nil cluster object. So they would need to add that check. That's basically the idea over there.
And so this is something that will work with the existing actuator interface, and I don't know that we've talked about changing the interface, but making
the interface doesn't change. It is basically that the interface takes a cluster object and a machine object. So the cluster object can be nil now. That's a change.
I looked at the PR a little bit. I think it's pretty straightforward and it looks good. I saw that you also added the release notes, which are nice. The only thing that I was thinking about is like now that it's nil, we should probably make it very explicit in the interface docs that could be nil and the cluster is just opt-in.
Yeah,
or provide some sort of like the other thing that I thought about was to provide some sort of like a default like dummy cluster, but that's like probably like down the line. I don't know if we want to do this right now.
I don't think passing a dummy cluster object is interesting, but I don't know if that's the right thing to do. Because it's hard to it makes it harder for the providers to figure out, is it a default object or am I supposed to do something else here or what?
Right. So that's probably for later to discuss.
I'll definitely add the doc comments. I'll update the doc comments on the interface.
Yep.
So one question that I have with regards to separating them is right now we do store some information that is needed for within the specific provider implementations right now. Would the idea be there that it would be a provider implementation specific thing that the cluster would be required, or would we expect that there be another level of defaulting on the machine side for provider implementations?
Right now, the idea is to have it be provider dependent, and then figure out what we have to do next. This only makes it. This only basically says the cluster object is optional.
All right, thanks.
That's basically all I have on that.
I remember there was a separate issue maybe file that was related, and I think one of the alternatives was to make the cluster optional or cluster object optional. One of the alternatives I think was to actually remove the cluster object from the machine actuator interface. So what would happen is instead there would be a reference from the machine object to the cluster object, and so in that way the provider, the machine actuator would check if such a reference exists, and if it does, it would fetch the cluster object that way. But yeah, that's something I think to discuss, I guess, down the line. This change doesn't change the interface.
Yeah. Okay. All right. I'll add the docs I'll update the docs, and then we'll merge it in a day or so.
So I have a quick question. I mean, can you maybe just briefly talk about maybe what the benefit of, like, what maybe the use case that you're specifically looking at when you do pass a nil cluster? What would be the benefit of that? I personally haven't really gone through the PR yet. I'm just going through it, but some background will be helpful.
So
thank you.
The idea is that regardless of whether the provider expects a cluster object or not, right now we completely block the provider from doing any actions if the cluster object is not provided. Right, the actuators are basically just blocked. So this just makes it possible for them to run some actions even if the cluster object isn't present. And if they were, this also makes it possible to have, if you have a bespoke cluster implementation, you can still use the machine implementation regardless of that. So it kind of allows you to have two separate, use the machine APIs without using the cluster APIs eventually.
Okay. I mean, so the question maybe I have is, like, I get that you probably want that we should be able to create machines, and the call, the call should basically get to the actuator to do something.
Right.
Now, my only concern is, like, let's say even if that actuator comes in, like the call to the actuator goes in with the machine spec, and let's say the cluster object is not there yet. Now, if you just at a very high level think about what the actuator does, it will basically create an instance on whatever the cloud provider it is. And for most parts, I think, whether if you're creating like the master, probably it's okay. But if you're creating a worker, you probably need some more additional information. But I'm still trying to kind of understand, like, we do need ultimately that we do need to tie that machine to a cluster. And if there is any sort of information dependency that, information about, let's say, the cluster that needs to be part of or somehow linked to that machine, would that have any implication in here?
So we assume that it would. It's just that's not everyone uses the cluster APIs, but more providers want to use the machine APIs. So the cluster references or whatever information required to create the machine, the actual instance, can be part of the provider spec as well, right? So there are ways around this problem that people might be doing today or want to do.
So just to add like a little bit of more information on this, I opened 639 to revisit actuators, and I think this ties into it because one of the things that we discussed is that the concept of cluster actuator actually in the provider sets up like, for example, VPC subnets or load balancers, and some of the providers don't need that. Also, we don't have a concept of like control plane actuators, which we might want to add later on. And so this might answer your question. So the whole goal is to pretty much like say the cluster, which actually just sets up infrastructure for the provider, might be optional. And this is a confusing concept. So this was also like the next topic on the agenda, but it was mostly to revisit like how do we name these actuators and also like where do we go from here?
So one of the issue that I don't know, I mean, this may or may not be an issue for every provider, but I guess one of the usefulness that I see of the cluster object is if for the given entire cluster definition, which includes like cluster and the machines and the machine sets, whatever that may include, if there is like a common set of information that needs to be common across all of these objects, let's say, that are logically belonging to a cluster, to me, it seems like the cluster object seems to be the right place where we can put that common information. One example that comes to mind is, for instance, when you're creating the Kubernetes cluster, we all need to configure the Kubernetes cluster with the underlying cloud provider configuration, and that configuration, to my knowledge at least, would be one thing that is like going to be common regardless of how you create the machines, but essentially for a given cluster and the given set of configuration, you want to have a single set of spec driving that cloud provider configuration file or config essentially onto the cluster. If we make the cluster optional and we break down that information into all the different machines, then it kind of becomes, in my opinion, a little difficult to reconcile that, because now you have a possibility where somebody could create different machines that eventually are going to be part of the same cluster, but they all might have some slightly different variant of that information that feeds into the global, so to speak, like the global cloud configuration setting for that Kubernetes cluster. I hope that makes maybe a little bit sense.
Yeah, I think that makes sense. That makes sense to me. It's a very valid point. I think that could be achieved also with machine classes to share configuration between different machine, or like, I mean, the provider that you would be implementing like could just like keep using the cluster for now. I mean, I don't think that's gonna go away. It's just optional for some other providers to pretty much not use it. For example, if down the line we're going to use EKS or GKE as like a variant or flavor, you don't have like the ability to customize the control plane instances or to set up like any flags, for example, for KubeADM or something. So the cluster in that case, I don't think will be needed. So that is one of the use cases for it, I think.
One
So
thing
just to extrapolate.
one thing I talked to a couple of people at KubeCon about was right now, cluster sort of conflates two things. One is that it sort of defines the control plane for a cluster, and the other is that it defines sort of cluster-wide properties, which is what Siddharth is talking about. And I think a lot of the cluster-wide properties are required for many of the machine actuators because they define things like network ranges and so forth. I think it would probably be worth maybe splitting those concepts apart and having a separate API object that is really just the control plane. And I don't know if cluster becomes the right name for the properties that apply to all machines, or if we can pick a better name for that. But I think that making those things concretely separate makes a lot of sense. There were also people at KubeCon who were hoping that we could split those things into two different API groups as well.
Yeah, I mean, I think I like that idea. I mean, essentially, to what Robert is suggesting, I think I like that idea. If we can have like some sort of a concrete API which can govern, let's say, the cluster-wide things, that's something that needs to be shared across all the machines, because to the point of use of machine class, the way I see machine class is like you can define one sort of variant of your machines with one machine class. I can have within a cluster, I could actually use two different machine classes to basically roll out two different group of machines, for instance, right? So your machine class, yes, it's common across a set of machines, but that may not be all the machines that comprise your cluster. You may still end up having, be able to use multiple machine classes for a given cluster. So having maybe either creating a separate object which can really cleanly define a cluster-wide configuration. Yeah, I mean, then that definitely makes sense.
I have a question on the implementation. So is this if I have a provider that is not checking, or let's say, sorry, is assuming that the cluster, that there's a cluster object being passed in, will this potentially break? I mean, have cause a seg fault for?
Yeah, it'll probably cause a seg fault.
So okay, so that's I think that's something important for providers to know about, even though it's probably the case that for a particular provider, right? If they need a cluster object, then there's going to be a cluster object, and most of the time, but it'll be a surprise, right? If there's no cluster object, then there's this unexpected seg fault.
Right.
I also had a question. Maisim, you said it was blocking certain use cases, and what I'm wondering is can you work around this issue by passing in a dummy cluster object, and why is that? If that's not a good workaround, what is
So
yeah, what was it?
It assumes that you would have to define the cluster CRDs as well, and you might not want to do that either. Right, so like I should be able to create the machine set, machine deployment CRDs without ever creating a machine class CRD or ever registering the cluster CRD. So at least that's what I was thinking.
Okay, so those are the trade-offs. So not creating CRDs, but then the actuators need to, if this change is merged, the actuators can no longer assume that there's a cluster object being passed in.
Right. So that's why it's also part of the release notes.
Yeah, and I think to that point, there were also a number of people at KubeCon, I think specifically the OpenShift folks, the COPS folks, and maybe one other group that was saying that they really want to adopt the machines API and don't really care about the cluster API part of it, like the part that's currently in the cluster API. And I think this is the sort of thing that puts us one step closer to allowing them to do that, right?
Yeah, and if we are concerned about people not reading the release notes, which hopefully we're not too concerned, we could change the interface signature in some way to force realization, because force it to be a compile time failure.
How would you propose changing it to force a compile failure?
One way would be to just add another method or change the signature of a method in some way. I don't like the v2 method or the v3 method, right? Where you just basically define, but that is one approach where you define a method which is sort of like a sentinel method, but doesn't actually do anything.
I guess we could just combine the ideas, the control plane, renaming cluster to the control plane object, and merge the two together, and that'll break.
I mean, I think this is a result of like the wrong abstraction, and we're just trying to fix it, which I think it's fine, and we can revisit it later when we have clear ideas and requirements.
So I have a follow-up question regarding the use case for this. I mean, so from what I heard, I mean, like people want to use maybe like GKE or EKS, some other services where they just want to use the machine APIs. Now, in that particular use case, are you guys thinking that the cluster API will still create the actual master nodes, or are you looking at only the cluster API to create, let's say, the worker nodes?
I would imagine it could be used for both, but the majority of the use case that I've at least heard about is using it for the worker nodes.
Okay, so would it be fair to say that, you know, regardless of it's kind of like we want to use cluster API as a means to, let's say, extend an existing Kubernetes cluster in a generic way, and we just want to use the machine APIs to do that, where, you know, the cluster API is not managing the entire cluster, someone else is, but you're just using it to extend it in a certain way. Would that be fair to say?
Yeah, and that's how I understand the OpenShift use case also, which is that OpenShift already has tools to manage clusters, but they want to improve their machine management, and they'd like to improve it in a way that's compatible with where the direction of our SIG is going, and so they can also reuse what we're building, right?
Just to chime in and comment a little on this, I think there are two things we have to differentiate here. The one is the API as types and API group, and the other is the implementation of this machine actuator. And the implementation does currently not really support not using the cluster part of the API, but I would argue the implementation is sort of a default you may or may not use, and if it doesn't suit your needs, you could also add another one to the upstream repo or build yourself one downstream. Yeah.
So one thing is, like, given that the use case here might be to extend the existing cluster, would it be possible maybe that we can add additional field inside our cluster object just to symbolize that, you know, it's like import a cluster into the cluster API concept? So that way, you know, you still have a cluster object, but, you know, it has a special flag or something that says, you know, I don't do anything really with it because this is something like externally managed, but it still fills in the same placeholder and keep the rest of the, you know, workflow in the same way as it would otherwise do.
It makes the user experience really funky because I now see a cluster object that I cannot change or interact with.
But it's true, but then, I mean, having, you know, I mean, hopefully what I'm thinking is that cluster object, when you look at it, I mean, it's clearly from what's inside that cluster object, you should be able to see that, okay, this is an externally managed cluster. So it doesn't have anything like meaningful in it, just like a reference to, okay, you know, it's an externally managed cluster. So it's kind of, so the point is, like, someone who's, let's say, familiar with the cluster API and the way it is being used today goes and suddenly has to interact with this kind of a cluster, and they look at that cluster object, but they can clearly see that this is an externally managed cluster, so they don't really do anything with the cluster, but they're just creating worker or additional nodes for that matter. I mean, I don't know, in my mind at least, that seems, I know it's an additional object that we create, but to me that's like a more explicit placeholder to suggest anybody or any controller for that matter that this is, an extension, and this is not really a managed cluster by cluster API, like the management or the control plane. Because having nil kind of suggests that, but that is like, it's kind of saying that if the value is nil, then assume that it's a managed one, but it doesn't make it concrete, like where is that other cluster living, or what is the information about that other cluster. Whereas if you do make it a cluster object with some like references at least, it makes it concrete in the way that now we can explicitly look at that object and actually say and tell about the cluster that, yes, it is an external cluster that we are just extending, and here's some sort of a reference to where that lives.
I don't think the distinction is managed versus not managed. I think it's sort of more like existing system versus new system, right? So if you have something like COPS or OpenShift, where they already have an API that sort of represents what the cluster is, for them to have to replicate that information into another API object because the common code in the machine controller fetches the cluster API object. I think that's the distinction.
To Robbie's point, like it's having the cluster object. It's not like he said, it's not about managed or unmanaged. It is like we want the machine actuators to be able to do something, even if the cluster object is not present. Right now, they cannot do anything if the cluster object is not present. Right? I think I see that as a bug, and this fixes that bug.
So, yeah, I think the challenge here is how do we represent the common information for machines that are part of a distinct Kubernetes cluster without necessarily having to buy into all of the cluster CRD and controllers.
Provider dependent, right?
Well, not all of it's provider dependent. So like the API endpoint that you have to do to bootstrap a node into a cluster is not provider dependent. And the same thing if you're, the pod and subnet CIDRs are less so, unless you're talking about specifically being also able to bootstrap control plane instances and not just worker nodes. But we do need, I think we do need to solve how do we bubble up that kind of common information and still make that available. Otherwise, that needs to be replicated at the machine level for every kind of machine that you have to create or machine type object.
So I can imagine a use case where you create a machine. So you run a machine controller and you pass in the whatever configurations that you have for that specific cluster as parameters. Right? You could have your actuator take in any sorts of parameters, and it could take in those startup scripts as well. It could take in the bootstrap configuration or whatever is required at that point. Right?
Well, if you do that, then you're just limiting what kind of the scope of the machine controller is today. Because today the machine controller doesn't limit just being able to spin up machines for just a single cluster, but it should potentially be able to spin up machines for multiple clusters.
Yes, and in that case, you would probably want the cluster object. But if you don't have the cluster object, or like it's it just enables a use case. It doesn't prevent the other use case from. It enables another use case and from the use case that you're defining, because both are applicable and both can be done today.
I mean, I think maybe if I understood what Jason just said and what you suggested here right now, that maybe as a parameter to the controller, the challenge with that is like, yes, you can probably start one instance of the controller with seed information from whatever the cluster that you're extending. But then what happens if you want one more cluster to extend? Like, then you're kind of you can't do that, because then you have to either run another instance of the controller with the new information, seed information or parameters, so to speak, from the other, it's the second cluster that you want to extend, which is not essentially, you're kind of bounding yourself into operating into just one cluster and not necessarily more. And I think that's what probably, I think Jason was hinting, correct me if I misunderstood, Jason.
No, that's correct, and it also limits you to not being able to really run multiple controllers, in the same, cluster for the machine object as well, because you would basically be reconciling the same objects using different base parameters.
So do we?
I was saying,
Go ahead.
I was just saying that I see those as two different setups and two different configurations of the machine controller. One in which the machine controller, all the machine objects are defined in one cluster, and the machine controller is able to create machine objects for multiple clusters in that world. The other use case is that you have a dedicated machine controller per cluster, right? And I see that both as valid options and valid configurations.
I mean, I think, but having to make that choice, like whether it's like you, rather than putting the controller to say, you're running as a controller, you're operating in two different modes, and you can only have one or the other. I would rather think that, you just still run the controller in one mode, but yes, you can realize both the use cases. That will be ideal. Will be, I think, the most flexible. And I think, going back to the previous suggestions, maybe if we can figure out a way to represent some common information, maybe not in the cluster object, maybe we can create a new specific API type for that. Because anything, even for, let's say, the extension case, I'm sure there will be some information that is needed by the machine actuators to operate upon, to basically add that to use them to extend the existing cluster. So any of those kind of common information, if we can either with a new object, which, not a cluster, but kind of feels like a cluster, but not exactly a cluster, but you can still create, sort of a global pseudo cluster-wide object that you can then refer, where you can put in some information, common information, and then you can operate in that mode, wherein, you can have both a mode where you have a concrete cluster object existing today as it does, and then another way where you don't have this cluster object, but you still have that global configuration option, or which you can actually use to drive anything commonality across the different machines that you want to extend.
So as this is a little contentious, we should, I think, take it offline and talk in, have the discussion in the PR, and maybe reconvene in a later meeting to figure out what we want to do here.
Yeah, it sounds like that would be a good way to go. We're 35 minutes past the hour. We have a few more topics to discuss. I guess it would also help for maybe providers provider implementers to take a look at the PR, and maybe in the PR we can call out whether this change is sort of okay in the interim, or whether if merging the change somehow changes fundamentally the design, and yeah, go from there. So I think, Mython, you had another topic, which is adding a provider ID to the machine status or spec, and using that to link machines and nodes.
Right. So so there's a PR open. I forget who opened it. Let me see if I can pull it up. Where someone was extending the machine status to add a provider ID. I think it's 565. So right now, the way we link the nodes and the machines is via an arbitrary annotation on the node object. Sorry, on the machine object to tell, it's funky, it's weird. I think it's added on the node object, and then it has the name of the namespace and the name of the machine that it's relates to, right? We were thinking that it would make sense to, instead of using that arbitrary method to actually just use the provider ID that is defined on the node object today. So if the machine object can, if the machine controller can add it in the status or the spec what the provider ID is, we can write a generic controller. I have a working prototype of that, which would link based off of that instead of an annotation. I'm not sure if it goes in the spec or the status. I think that's up for discussion, but I wanted to know if that's something we want to consider. I can link the PR the change that I have somewhere.
Any comments or objections? I think there's been pretty extensive discussion on the PR as well, so maybe it can continue there.
I guess I would try to summarize and see if people agree with my summarization as a sort of straw man type thing. It feels like everyone has agreed that we should have such a field, and it feels like the debate is spec, status, or annotation. And yeah, I guess that's where I would stop and be like, is that the case? And then if that's the case, I think we just need to pick one and move on.
So I was going to say, if the argument is that we should be able to pass in kind of pre-existing machines, then it would definitely fit under the spec. Otherwise, if we consider it just something that is just kind of an artifact of the reconcile and can be recreated at any given point in time, then it should be status. I think we should avoid annotations if at all possible, and be explicit.
So on your point, so in my opinion, it should always be recreatable, the provider ID, because the machine actuators should be idempotent on creates. So they should be able to, using the machine spec, they should be able to generate the provider ID. Otherwise, like they will leak resources.
I guess Jason was calling out another use case, which is I want to adopt an existing machine, right, Jason?
Correct.
Which feels valid to me. A little bit like, I imagine many providers will not support that, but I imagine for bare metal it is likely to be important. Maybe.
Yeah, I guess the other thing, Messim, to point out is on providers like AWS, you can get a provider ID or some field sometimes only on create, and then you can never get those values back again. And so sometimes it's useful to store those things in a way that when people are pivoting resources between clusters, you don't lose it.
That's fair.
I think VMware had a use case like that too.
Yeah, I don't know what you're talking about. I don't know what you were referring to on AWS, but okay.
I thought someone told me that on AWS when you create a machine that it gives you back some information that you can't get later, like that you only get on the create call. Maybe that's not true.
It might well be true. I just can't recall what that would be.
As far as I know, might only be the request ID, but anything else on the machine should be, yeah, you should be able to get it afterwards.
Yeah, the only thing I'm thinking of is like AWS IAM credentials when you create like a secret and you can see it once, but then that's it, right? But that might even just be in the UI rather than actual API calls.
But if you do that, then we have to talk.
But yeah, I mean, let's assume that there is such a thing in some other clouds, maybe.
Mm-hmm.
I mean, one other distinction here is, I mean, yes, VMware, we do have a use case where, for example, if somebody has created already a virtual machine, we want to import that I personally actually use that in a very different way, but in our product internally. But having said that, one of the other thing is the provider ID. Yes, it is a unique identifier to point to the underlying VM. But for example, I can talk about, for example, in vSphere, in specifically for that case, we have a concept of managed object reference, or a MORF-ID as we call it, which is essentially like the unique ID for a VM, like kind of a handler to the VM on the vSphere side. Essentially, it is, and this is not the same as what the provider ID, for example, for vSphere is needed, because the provider ID is more of, I think it's the UUID, instance UUID that is part of the guest OS, which is being populated up as a provider ID that is utilized by the vSphere cloud provider to basically link things up. So again, the provider ID, what I'm trying to make is, that may or may not exactly be the very string that all providers would use to basically say, link me back to what the VM or the instance that I've created to this. I mean, it might be two different things as well.
That feels surprising to me. Like I think the provider ID is supposed to map to the, in the node, the cloud provider, it's supposed to map to a particular instance in the underlying infrastructure by the cloud provider, right? And it is specified by the cloud provider, but.
Yes, I mean, essentially, so, okay, so let me maybe correct myself or rephrase myself as well. I mean, so the ID, so the MORF ID that I've talked about, so there are number of ways, I guess you could say, how can I look up a given instance on the infrastructure? One way is using that provider ID, that instance UUID that we get, that we are setting. Yes, we can also fetch the same VM with that ID if we need to. That is possible. But we also have another mechanism in our infrastructure with vSphere, which we have, as I said, MORF ID, which is from the API point of which is a much more straight and a direct connection to basically fetch that object from the backend, as opposed to the ID would be a lookup kind of a thing. So it's more efficient if we have the MORF ID, so that way it's slightly better. But again, yes, you're right. Provider ID still, yes, uniquely identifies the infrastructure, like the VM on that back infrastructure. That is true, even in the vSphere case.
I think I understand better what you're saying now. GCE or GCP, GCE has a similar concept where they have instance name and instance UUIDs, and instance UUIDs are the better permanent identifier, but instance names are how you actually query most things. I think that's what I wrote, right, Bobby?
Say that one more time.
That GCE has instance IDs and names, and instance IDs are the permanent ones, or UUIDs, but instance names are the primary querying mechanism.
Yeah, I think most people refer to machines based on the name, because that's also guaranteed to be unique within its scope, right?
But not across time, which is the problem, right?
At a given point in time, yes.
Yeah. All right.
So maybe we can also continue this discussion on the PR. We've got a few more topics, and it's about we have about 15 minutes left.
I'm going to try to be as quick as possible. So the revisit actuator is a larger issue that we might all need to discuss. There are a few ideas. The first one is to rename the cluster actuator to a control plane actuator, and which would be optional, which seems like we need to discuss about that. And maybe make the machine actuator being worker specific and not actually spin up cluster control plane and worker nodes at the same time. And the other thing is to separate the right now the cluster actuator, as I was mentioning before, creates VPC subnets and load balancers. So we could have I don't know, cloud setup reconciler, which is completely separate. And again, this would also be optional, because then we could also use other existing technology like CloudFormation, Terraform, or whatever you want to use to fulfill the requirements of setting up a cloud environment. So just wanted to raise some awareness on this, and if there are any ideas, please do add them to the issue. It would be great to have more use cases.
Nothing requires you to use the actuators today, right? So like you can experiment, and Mason can experiment, and do whatever you want. And we would like everyone to come to the same or a similar API, but it may be that machines are similar and cluster ends up dissimilar, at least for now.
Yeah.
So I have a question about the first one, renaming the cluster actuator to actuator. What would be the motivation of doing that?
I think I phrased this wrong. Like I should rename, rephrase this as like introduce the control plane actuator instead of renaming the cluster actuator. But the idea is also like right now we have like control plane configuration inside the cluster actuator. So that will probably move out if the cluster actuator is fulfilled as an interface.
Sure. So the SSH provider uses the cluster actuator for exactly one thing right now. Well, that's not true. We also use the service and pod providers, but we depend on the API. The reason we do that is we would like to be able to deploy all of our machines, and we want some of the machines to be control plane nodes because that simplifies our upgrade story later, when we can selectively delete individual control plane nodes and then wait for another one to come up. But since both workers and control plane nodes are represented as machines, and since we kubeapply all of these at the same time, what it means is that during the time when the control plane nodes are being created, all of the worker nodes can't be created. And the way that we determine when it's okay to start creating control or workers nodes is by looking at the API endpoint. That's the field that we use to determine that there is a control plane and it's safe to join. There's a couple different things here, but I guess for our implementation, I would prefer that control plane nodes be represented as machines, and we need some higher level concepts like cluster or control plane in order to represent the state of the control plane.
Yes, that's exactly like where I think I was going for this. That doesn't mean that like the control plane wouldn't be a machine. It more means like the whole setup and configuration would happen as a step before. Even we have the same problem in the AWS provider that like we need to wait for example, like the cluster actuator to finish before running the machine actuators. And right now we do that kind of on our own by checking some of the parameters and not waiting for the first run of the cluster. But that's more a dependency issue. So.
Sure. I guess my wonder is why can't we just use the cluster actuator for this? Like, is there a reason to separate it out?
I think the concept, at least like when I joined, the concept was very confusing that the cluster actuator would set up, I mean, we could create the control plane in the cluster actuator, sure. But the concept of creating also like a VPC subnet and like all the other things that set up the provider, it's kind of confusing for a newcomer. So I would work to like bring that logic out like something else and actually like set up the control plane on its own and make that optional for like for other use cases that like don't want to manage control plane.
Yeah, I think this early in the project, right, we're still alpha. We want to think about the naming, and if we're going to be happy, 6 months or a year from now when we're pretty much set in the way that we've named things, and if we think we might not be, now is the time to now is the time to reconsider. So yeah, I think good to good to think about this, and let's not just because we made the decision about cluster actuator early on doesn't mean that we can't change, but we may not be able to change later on. So
yeah, just trying to raise awareness. The other two things that I wanted to bring up is just the controller runtime and tools update, which also updates to Kubernetes 1.12. This still needs to be approved. This also removes the SIG dependency on the makefile, which, I mean, for me, like when I first pulled cluster API, was blocking on Mac. And the other thing is, this is an issue in the AWS provider, and this fixes Jason's PR about short-circuiting return on the cluster when we add a finalizer. This makes the first pass in the cluster machine actually to fail, because when we try to update the status or the machine or the cluster, the revision ID is actually already outdated because we updated here, but the cluster doesn't get updated, the object itself. So this fixes that issue. And I want to give time to David for Gitbook. So
I only have a little bit to say about that. So the current state of the Gitbook is that it's actually not online and live. The problem there is that in order to deploy it, you need a Git submodule called subtree, which isn't available everywhere. We have another problem associated with that, and that's that whenever someone makes changes to the Gitbook, we have to republish. And in order to publish, you have to be able to push to the GH pages branch, and this requires permissions that ideally we wouldn't hand out to the world. So a task that I've signed up to do is I would like to have a CI job which will automatically publish the Gitbook so that CI job alone can have the correct permissions and can have the right version of the Git modules necessary to publish. So all of that said, the other comment is just that, especially with all of the changes that we're talking about right now, it would be great if people could take a look at the Gitbook when they're making changes and see if they can keep the Gitbook up to date with the evolving API. So those were just my comments.
all right, and then to wrap up, I just wanted to ask if anybody who's attending today is interested in the quote-unquote generic provider, so a provider that doesn't target a specific cloud or a specific infrastructure API. David and I are working on a proposal. We expect to publish it next week, and that's of course when all the commenting and everything starts. But I just wanted to just to give a heads up. I know that last week at KubeCon there were a few people that attended the deep dive that Robbie and David gave, and afterward, had questions and were interested in the generic provider. So yeah, if you're here today, you can reach out, I guess, to us on Slack, and then of course when we publish the draft, and all the comments, we'll be looking forward to your comments.
I'd love to participate.
Great.
Sounds really interesting.
Yeah, that's I think that is it. Anything else? Going once, going twice. All right. Then with 2 minutes to spare, calling it a meeting. Thanks everybody for joining for the lively discussion. Please look at the PRs that we had discussed at length. The machine controller without needing a cluster object PR, and then the machine status, or sorry, the provider ID PRs, and yeah, the reviews at actuator PR, and then yeah, anyway, all of them. Please take a look, and yeah, have a great rest of your day.
Bye, everyone.
Bye.
Bye.